Hi, this is Dave Redder. This is a series of 3 videos regarding iteration in the iterator pattern. In the first video, which was about 8 or 10 minutes long, what we did was talk about an application that just does iteration, and it looks like this. It simply iterates through a list, displays them in a list box when you click the button, and there is the source of all of the names that were in that box, and here is the iteration. There's really not much to this, although in there we did discuss the iterator pattern to some extent, in particular the meaning of it, to provide a way to access the elements of an aggregate object, which is important, in a sequential fashion, which is important. And this is the part that we're going to deal with a little bit in this video and a lot in the next one on the iterator pattern, without exposing the underlying representation. So what I want to do is to look at the iterator pattern and see if we can convert this application to an equivalent application that implements it via the iterator pattern. And to do that, we're going to look at the UML diagram for the classes involved in the iterator pattern. There has to be an aggregate that you iterate through, and this is the thing that we're going to try to hide the storage mechanism, or the underlying representation as it says right here. And what we're going to do is create as you see here, an abstract aggregate class that indicates you must have a create iterator method, and then a concrete aggregate class which is going to contain in it the data for the aggregate, and then we'll create the actual create iterator method, which has this code in it. To do this, what we have then is a client that creates an aggregate object and then creates an iterator for that aggregate object. And the iterator looks like this. The iterator is the class is abstract again, having these 4 abstract methods. We have this concrete iterator class which will implement those methods. And it's important, I guess, for us to think about what these arrows mean. These arrows with the open head and the solid shaft are indicators that this thing that points to it, the client, has access to the aggregate class. The client class has access to the iterator class. And the concrete iterator has access to the concrete aggregate class. The dotted line for the shaft indicates that this class depends on this class. And then, as you probably know, these 2 arrows with the closed head on them indicate inheritance, that says that concrete aggregate is derived from aggregate or inherits from aggregate, and iterator is the parent class for concrete iterator, whichever one of those ways you'd like to say that. One other thing here is that this dotted line is simply an association line, and it indicates that create iterator has this code in it. It may have some other code in it, but this is the part that's necessary, required in fact, if you're going to claim that you have an iterator pattern implemented. So what we need to do then is try to decide what's the order in which we'll create these. Here's my thinking, is that since concrete aggregate depends on the concrete iterator, we should probably create the concrete iterator first. And the concrete iterator is derived from iterator, so we might want to create the iterator abstract class first. And aggregate is also need to be created before we create the concrete aggregate. I think what we'll do is just go ahead and create the aggregate class and the iterator class, and then we'll come back and create these 2 concrete classes. And since, as you can see, the aggregate class ultimately needs to have access to the iterator class, the concrete iterator method, we might as well create the iterator class first, and then we'll create the aggregate class second, because we need to say that create iterator is going to return an iterator object, and it just makes it a little cleaner to do it this order. So the first thing I'm going to do is create a new class, and that new class is going to be the iterator class. Add that. I'm going to make it abstract and public. And if you look at the definition of the iterator class, it's got these 4 methods in it. First, next, is done, current item. And it's convenient to think in advance about this as to which one of the, or what the return types are going to be on these. First and next don't return anything, but instead they change the state of the iterator. So that'll just be a void return type on those two. Is done tells us whether we're done with the iteration or not. In other words, it's going to return a true or a false. It returns Boolean. Current item is going to return one of the things in the aggregate. And for our purposes this time, as you'll see in a moment, the aggregate is going to be an aggregate of string objects. And so we're going to do the following. We're going to say public abstract void first, public abstract void next, public abstract bool is done, and public abstract, and then this time is the string current item. Well, I think it wanted to say this. We'll say this whole thing. Current item. So now I'm done with the with the creation of the iterator class, except for saving it. And I'm ready to go create the other abstract class. Add class aggregate. And I'm going to do the same kind of thing here. We're going to have public abstract class aggregate. And if you'll recall again, we have this method here called create iterator. And the reason we did iterator first was because for create iterator, we want a return type, and the return type we want is type iterator. So it makes it just a little bit more convenient for us this way. So I'm just simply going to say public abstract iterator create iterator. And I'm done with that class. Simple enough. Save that. And now let's go back and look. So what I'm going to do is create this concrete iterator. And the concrete iterator doesn't have anything in it specifically at the concrete level, but it will inherit all of these things from the iterator. So when we come here, I'm going to create a new class by clicking Add Class, right-click Add Class, and this is going to be called the concrete iterator. And I'm going to make it public, but I also want to derive from the iterator class. And notice that just as soon as it gets around to it, just a split second, it says, whoa, you got an issue here. Hover over that issue and it says, well, you didn't inherit, didn't implement these inherited abstract member methods first, next, is done, and current item. So we need to get all of that coded in there. But it also says, but I can help you. I'll implement it for you. So there's the implementation of those methods in the iterator class that are required because we inherited from this abstract class. And these are the abstract methods that were declared in there. We're not going to mess with these things just yet. We'll come back here in just a few minutes and we'll put some code in here. But those are implemented in that way just to kind of remind you, if you forget to do one, that is going to throw an exception and probably your code's going to crash when it gets to that point where it needs it. So let's create the concrete aggregate. Add class, and we'll call it concrete aggregate. And here we go. This is also going to be a public, and it's going to be derived from aggregate. And notice that as soon as it gets knowledge of that, it says, hey, I got a problem with that because you didn't implement create iterator. We know what's going on now, so we can just click on that and have it create that. But what create iterator wants to do is to execute a piece of code that looks like this. Return new concrete iterator of this. So that's what we're going to do. Return new concrete iterator of this. This being the current aggregate. But when we do this, you notice that it's got this underline, and it says, well, it doesn't have that kind of a constructor. It's only got one constructor, and it's the implied constructor. but it doesn't have a constructor in the concrete iterator class that accepts an argument. And in fact, it's going to accept an argument of type aggregate. There are actually two issues here. We're going to fix the other one shortly. But here it also offers help. We can click on that and it says, well, I'll just create that for you. And in fact, if you look over here, it creates it in the right file. It creates it in the concrete iterator class. So I'm just going to click on that. You don't notice anything right here, but you do notice in terms of changes in the code, but you do notice that this thing isn't underlined anymore. And in fact, if we go look in the concrete iterator class, you'll see that there's the method. It noticed that we're passing an argument, so we must need to store it. It even provides us with that place to store it. And we're in good shape now, except for one thing. When we come over here, this concrete aggregate needs to have some data in it. It needs to be something that we can deal with as concrete data. And so what we're going to do is we're going to come and steal this line right here. I'm going to cut that. Come over here to concrete aggregate. I'm going to paste it into the aggregate. And now we have a concrete aggregate with some data in it. And that's kind of what we wanted. If we look at what we had before in the form code, we really dealt with this thing, which was right up here, as the aggregate. Well, we've got to change that now, but all we did was move it to someplace else. And so now when this gets passed to the iterator, it will have access to this thing if we make it available to it, like that. So we're pretty close to where we need to be. But the problem is in the form, first of all, this isn't what we want to do. And we're going to come back and fix this. But the thing we really are going to want to do is to create an aggregate object in here and pass that aggregate over to create an iterator. And the iterator is the thing that we'll use to iterate through this, as you'll see in a few minutes. Well, let's go back to the concrete iterator. It's got methods in it, but they're all kind of method stubs. And we have this guy, the concrete aggregate, but we also need to keep track of where we are within the concrete aggregate. So I'm going to say current index equals -1. Oops. I'm going to create a variable current index. And this is where I know now within the iterator what the underlying structure of the aggregate is, but the guy over here in the form doesn't need to know. Looks like he does there, but he's not going to for much longer. So if I were to try and do these, notice by the way it puts these things in here in alphabetical order rather than the order that you specified them in the parent abstract class, but we'll live with that. So which one would I want if I was saying I want to start at the first one? Well, I'd want the current index to be equal to 0, because that's where the first item is. And in next, I would like to take whatever the current index is and increment it. And is done? Well, if we look over here in form, in this particular case, is done was true anytime this was false. In other words, is done is true when I is greater than or equal to 5. So we could do it that way, or we could do it this way by saying return is current index less than 5. But that's for if it's not done. But I want to return the value if it is done. So I'm just going to put a bang symbol in front of that, and that's my is done. And then the only thing I've got left here is this current item. And the current item is the one that's at the current index within the aggregate. Now, if you keep in mind, concrete aggregate looks like this. It's got this public string called names in it. And as a result, in the concrete iterator, I can say return the string from concrete aggregate, that's this guy up here, dot names of wherever we are, which is current index. So now I've got all of these methods specified. names got passed in with the concrete aggregate argument to the constructor, and that came from this string, which is the same one we had before. And now all I need to do is to look at the form, and instead of using this old style or this non-iterator pattern version of the code, what I need to do is to change this so that I've got an iterator. So what I'm going to do in here is I'm going to say concrete aggregate ag equals new concrete aggregate. And now I'm going to say ag dot create iterator, which calls this method create iterator and calls this argumented concrete iterator constructor. So now I've got this iterator that I get back, and so I want to use it. I'll just call it CI for concrete iterator, and it's the concrete iterator I get from this particular aggregate. Then I'm going to change this. Instead of doing that stuff, let me just mark this so that it's still visible and we can use that as a guide. But what I want to do is this: for concrete iterator dot first, that's what I equals 0 did for us earlier. I less than 5 is saying that I'm not done, so I'm going to say not ci dot is done, and the I++ is ci dot next. And then the next thing I want to do here is simply say I want to add this item to the string ci dot current item. So let's run this and see. Oh, I've got these guys have to be methods. My bad. That's a method. That's a method. And let's save everything and let's give it a run. So now we're fully using, as you can see in the code, we're fully using the iterator pattern. I click on that, I get the same result. That's what the goal of this whole application was. So you can see right now that instead of doing this kind of thing, I've done this kind of thing using the methods in the iterator, the methods required in the iterator, and the concrete aggregate contains this value. Now, if you wanted to clean it up a little bit or make it a little bit more useful, maybe you would simply have the ability to pass this string of names or add names to the string from within the form where the user provided them or whatever. But in any case, this allows us to iterate through that list. Notice that in here, we've absolutely said nothing about the underlying structure of the concrete aggregate. In the old version, we talked everything about it because we talked about we assumed that it was an array. Here we don't know. And in fact, we could use exactly this same code and modify the concrete aggregate to be some other kind of an aggregate and modify the iterator to know that and to get through the other aggregate, but the form would never know the difference. That's the beauty of the iterator pattern. And in fact, that's the beauty of many of the patterns in this course. So I hope that's of value to you, and we will look again at the iterator pattern in the part 2 video. This is part 1b, and the part 2 video is going to have in it for a nonlinear structure rather than having just an array. This seems like a lot of overkill to iterate through that concrete aggregate, but if this thing's ugly in some way, some nonlinear way, then maybe we'll have a better feel for what the power of the iterator pattern is. So until then, I hope that this has been of use, and I will talk to you later.